Good morning, everybody. On this, I believe, Thursday, where we have made it through our first real chapter, chapter 2. Hopefully, everyone is up to speed with what has been happening, and we are ready for a new chapter with varying degrees of difficulty. It's certainly not the case that every chapter will be more difficult than the previous one. They're just different topics. First, let me check if everyone can both see and hear me, like always.
Yep.
All right, perfect. Now we have 3 days scheduled for chapter 3, which is kind of overkill, but it means that we can take our time, ask questions as they come up, have discussions, and have a more relaxing time. As after chapter 3, we start thinking about our first quiz and things like that. Exciting. Okay, so we are talking about general problem solving. Now, it's a very open topic, and in general, there's really no limit to the difficulty in this topic. There are still problems that people are struggling with. Now, of course, we will contain the difficulty to our goals and our needs. Some will be there to make us better, and some will be there to be directly relatable to our elementary school curriculum for some grade. Let me get my pen ready here. As we go, though, and in general, let me write my title here. General problem solving. Regardless of the difficulty, really, regardless of the subtopic or the problem you're looking at, there's a problem that needs solving. There are some guidelines that I can keep in mind as I proceed. Some of these might be obvious, but you'd be surprised how quickly they go out the window when I'm stressing about the details of a problem. I want to remember some steps. Steps. There are many ways to break this down. This is mine because I like it. Well, actually, I stole it, to be honest. Long ago, I saw a little sign that did it this way, and I thought, that's cool. I'll take that. When you approach a problem, the very first thing I want to do is stop. Just stop whatever you're doing. So many times people come into a problem assuming the worst, or they're prepared to have a whole thing happen, a whole calculation maybe. I have to just stop and just prepare myself for whatever this problem is going to require and give me to work with. It's very dangerous to bring in your own assumptions, like, oh, the next problem is going to be the worst one ever. And then if it's not, you overthink it and everything gets bad very quickly. I want to think about what the problem is asking. I cannot continue if I don't understand the problem. What is it saying? What is it not saying? Just what do I have to work with? What is it asking? Is it asking multiple things? Very often, a problem is asking a specific thing. And I've seen people wanting to answer other things as well. And there might not be information to be able to answer other things. I'm only tasked to answer the question that is stated, not more and not less. So it's very important. I cannot move on. I should not move on if I don't think about the problem and understand the problem. Okay, so let's maybe say a couple of things here. Stop. Don't bring any assumptions. Let's say it like that. I see people do this. Oh, it's a test question. It's going to be the worst question ever. And they overthink it and they freak out, and you don't do as well as you can do. Think about the problem. Understand the problem. It sounds so silly, but it very easily falls apart. I rush. I go too fast. I read the problem once and expect myself to remember everything. Those are all dangerous things. Evaluate means come up with a plan. Have a plan. Evaluate. Okay, how am I going to approach this problem? Now that I understand this, have a plan. Oops, not a blam. I don't know what a blam is. Maybe a plan. Have a plan. Stick to the plan. That doesn't have to be the best plan. Just have a plan. And you'll see this if you haven't already, perhaps, worked in elementary school. That's not how kids think. They just stumble forward and hope for the best. And they don't have a plan, a structure that can guide them through this question and get them to the answer. Something that you can trust, something that you can rely on. It doesn't have to be the best. It doesn't have to be the most efficient, but have a plan. I remember so clearly. I was in my second year. We had sort of tutorial sessions where we're given a sheet with questions, and we have to work on them and then ask. There are tutors walking around and things like that. And the instructor was there as well. And we didn't know what was going on, really. We didn't know really how to do the first problem. And I remember him standing in the front saying, don't think about it, just start writing and things will fall in place. And I remember even then thinking to myself, that is the worst advice you can give me. In math, it doesn't work like that. I'm not writing an essay where if I just start writing, my thoughts are going to sort of organize themselves, and it's a different strategy. That's not what I'm doing here. This is a technical topic. It doesn't work like that. Come up with a plan, however silly or inefficient that may be. Before you start, know, how am I going to approach this? And then, of course, I have to proceed with that plan. Stick to the plan. Stick to the plan. Let's say here, execute the plan. If we think about our previous logical puzzles, we have golfers that are lying or houses with colors and all kinds of fun stuff. We need a plan. How am I going to approach this? Which strategy am I going to use? There's no wrong or right answer necessarily. And sometimes it's personal preference. But it matters a lot, making it easier for myself. Execute the plan. And then sort of throughout this, sprinkled in here, in between here as well, I have to, let's say here, self-check or self-evaluate. I don't want to use the word evaluate again. Just check up on yourself constantly. Ask yourself, am I executing my plan the way I want it to? Is my plan working? Does my plan seem that it's moving me forward? So I want to always sort of just check up on yourself. Check up on yourself. And if it turns out, I thought I was going to lay it out like this. I thought I was going to have this plan and it's going to work. Turns out it's a little messy. Turns out it's a little confusing. Let's loop back. Do I need to adjust my plan? Or do I maybe not understand the question? Or did I maybe assume something that wasn't actually there? Always check up on yourself. What am I doing? Am I doing what I was planning to do? Is everything still looking okay? I don't mind going slowly, but I want to be working towards the answer. That is the important thing. Am I moving forward? Or is my plan holding me back? Am I not executing the plan that I had? Or it turns out I missed something in the question. Or I brought an assumption that wasn't actually there. You have to always check. It's unreasonable for me to assume that I am thinking about the problem in its entirety, completely, accurately, not missing anything, not assuming anything that's not there. My plan is perfect. Everything is just perfect. If that's the case, sure, you don't need to check up on yourself. Everything's perfect. But in reality, it doesn't work like that. Many things can go wrong. And if I don't constantly just check myself, I could make it much, much worse. So that last one is very important. I've added this. It's not in the book. I don't need a step plan. I need steps. I need to do many things over and over and over. Okay. Now, of course, I will adjust the seriousness of these steps according to the complexity of the question, right? Some of them are going to be very straightforward, and I don't need to obsess over every detail. It could make it worse. But we have a feeling that when I read a question, it's easy or it's not easy. And the more difficult I perceive it, the more I have to go slow and carefully do all the checks that I need to do. All right, that's enough rambling from me. Let's see. So there's some more in the book if you want to read it. Now, when it comes to elementary school level, for the most part, there's still some variety and difficulty there. We have some strategies that we want to be aware of. I don't want to feel limited by these strategies. It's certainly not a case that, oh, I have to pick a strategy and I have to stay with that strategy. No, it's just stuff to keep in mind, sort of broad strokes of things and approaches I can take. I could sometimes mix a couple of them together. I can do many things. It's just things to keep in mind, whatever works for the problem. So there are always useful things like making a table, making a list of examples, helping me understand the question maybe, and structure it. Sometimes the question requires that I have an end result and I need to work backwards. Sometimes, one that is almost the most important to me, I saw it yesterday in a grade 4 question. Just if the problem seems too big and overwhelming and I don't know the answer, can I make it simpler? Can I ask a smaller question first that isn't so scary, that can systematically lead me to the actual problem? This is not intuitive, but it is so, so helpful. Maybe I just draw a picture. It doesn't even have to be a necessary picture. Just visualizing something. It's amazing to me still. I don't understand how, but it makes a humongous difference. Very often, if not always. Just draw a picture, stick figure. Just make yourself feel better. It's important as I work through the problem to ask the right questions as I go. What is the problem asking? Is there maybe another question I should do first on the way to this big question? So on. Sometimes the problem is just mean and it's a trick question. And it's hard to spot, but they're fun when you look back at it. There are some classic problems that we definitely want to look at that can really add to our experience. Then we'll talk about inductive reasoning a little bit more. It might look a little different, but by inductive reasoning here, I just really mean recognizing a pattern to help me figure out what's happening. So it's sort of linked to the next one, exploiting a pattern. And sometimes trial and error is a strategy I want to have in my library, sort of guess and check. Try something, see if it's working, see how far off I am, and by trying possible answers, it might nudge me in the right direction. And we'll see that. But people, I think, misuse guess and check. It's not random. I'm just going to hope for the best and try some possible answers. No, it's more educated guessing and checking. Like every guess has to push me forward closer to the answer. It's not random. But using it correctly can definitely help. It could be a combination of these, could be just one, just things to keep in mind. Now all we're going to do is just build some experience with a bunch of examples. They differ wildly in complexity, and that's good because it's very important for me to practice not bringing my own assumptions into a question. All right, everyone with me so far? That was a lot of words. I was trying to stretch the time. I have 3 sessions here. I need to stretch this out. No thoughts at this time? I know you all fell asleep. It was 8:30. Rambling on was not maybe the best choice on my end. I apologize. Time to wake up. But the first one is still fairly easy. I, just for my own paranoia, just need to confirm that people are still alive on the other end.
Still alive.
Okay, good. I don't know. It's quiet. So quiet. So, exercise 3.1. Every one of these, regardless of how easy or difficult, they have something to teach me. And it's all about experience. To an elementary school student, it might seem like, how do you know where to start and what to do? But just take little steps. Every example makes you better. And in the end, it's not so intimidating anymore. Exercise 3.1. How many different 4-digit numbers have the same digits as 1987? So I have digits 1, 9, 8, 7. Now, of course, there are some things that I have to cover that I can't assume you've thought about before. I can't assume you've seen it before. But there are things that you need to see. So if at any stage I'm boring you, feel free to open a YouTube window or something else. I can't assume that everyone has thought about stuff like this. So I have 4 different digits, and I need to shuffle them around in all possible ways to make all kinds of different numbers. How many ways can I do that? Now, if you give this to little Timmy, it's not hard to understand what to do. Shuffle these digits around to create other numbers. How many different numbers can you make? What would you say he's going to do? Once he understands the question, he's now left on his own to see how many ways he can do it. What do you think he's going to do?
Start a list?
He's going to start a list, but how? How is he going to make that list, most likely? If you imagine little Timmy, what are they likely to do? They're just likely to randomly shuffle them around. And hopefully they get them all. The problem with randomly making your list is it's very hard to be confident, especially at that level. It's very hard to be confident that you have all the arrangements. So randomness is never a good idea here. I want to make a list for sure, but I want to do it in a way that gives me confidence that at the end I have all the possible arrangements. So I want to have some structure behind my list. Now, just to help me, I'm going to write them in increasing order. 1, 7, 8, 9. That's the first one I'm going to start with, just to help me. Of course, it could be any other one to start with. Now I want to make a plan so that by the end, I am 100% confident I didn't miss one. And if I just randomly shuffle these around, that is not going to happen. I will not be confident. I can't just hope for the best here. So what I'm going to do is I'm going to fix the first digit in that position. So the 1 will stay first. Come on, you can do it. 1 is first. Then, because I have so many digits, I'm going to keep that 1 for as long as I can in that first position. Because then I've made my problem simpler. By not worrying about the 1 right now, I only have 3 things to shuffle around. Now maybe that is still a little bit intimidating. I can fix the 7 in the second position as well. Let's go blue. Let's go squigglies. So for as long as I can, I want to fix the 7 as well, so that I reduce my problem to shuffling fewer things. And now I only have to shuffle 8 and 9. But that's a much easier thing to do. And the only way to do that is have 8-9 or 9-8. So now, remember, I'm always checking myself. And I'm imagining that I'm little Timmy as well, and this is not easy. Now I know with confidence that numbers starting with a 1 and a 7, these are the only two. There are no others. I've made my job simpler as part of the bigger question. So I'm going to keep the 1 for as long as I can, but now I have to change the 7 because I've run out of options here. So I'll go to the next number. I'll just go increasing so I don't miss one. Will be 8. And I'm going to keep that for as long as I can. And then the other 2 digits are easy to shuffle around with confidence. It'll be a 7 and a 9 or a 9 and a 7. And now I'm still sticking with my 1 so that I only have to look at 3 digits. There aren't any others with an 8 in the second position. So I'm trying to give myself some structure by reducing the number of digits that I have to shuffle around. So I'm fixing digits in the first places so that it's easier to shuffle in all possible ways. So I want to stick to the 1 in the first position. I've now run through almost all the options for the second position. The 9 is still out there. And then I have a 7 and an 8. And the only ways that can happen is one way or the other way. Because I have only 2 things, I'm confident that I'm not missing anything at any stage. Now I can say, well, I want to keep the 1, but I've run through all my second digit options. I have no other second digits of these black ones, 7, 8, and 9. So then I can conclude with confidence that these 6 are the only arrangements that start with a 1. I've gone through them all systematically, which means if I want to make more, I would have to pick another digit to be first. So then I'll go down the list and say 7. And I want to do that for as long as possible. Where is my pink? Can I get something that's pink? No, I can't. There it is. So I want to stick to this for as long as I can. Okay. I'm going to stick to 7s. 7, 7, 7. Now, I also fix the second digit, the blue squiggle. Maybe pick a 1 there, then 8, 9, 9, 8. Only options. Then I'd have to update the second position, maybe to an 8. Has to be 1, 9 or 9, 1. No other options in this small stage. Then I have to update the 9 to be in the second position. What's left can only be 1, 8 or 8, 1. So now it depends on the experience, of course, of little Timmy. Some might see, well, when I started with a 1, I made 6 different arrangements. When I changed that to start with a 7, I made 6 different arrangements. So following the argument, I might not need to see all of the ones that start with an 8. There's going to be 6 of them. But some people might have to see that list, right? Starting with a 9, shuffling all the other places, there'll be 6 of them as well. But it depends. Some people won't feel confident with that and might have to make the list in the exact same way. Totally fine.
Is this inductive reasoning?
Well, it might sound like it, but I don't think so. Because I'm 100% confident that by following this argument, I'm just sort of copy and pasting the argument, but starting with a different digit. There's no doubt, there's no limited examples that I'm using to make a general statement. These are all of them. But it does have inductive reasoning tendencies, doesn't it? The way I see inductive reasoning in its original form is I do not have all the examples, and I'm making a general statement that I'm never going to be 100% confident until I have a more logically sound deductive reasoning argument. All we're saying here, now it might look like what we're doing here. All we're saying here is look at my argument using a 1, and then notice that if I use a different digit to start with, the argument holds exactly the same, but I create 6 more. So it's not quite an inductive reasoning leap to conclude that I have 6 arrangements starting with an 8, 6 arrangements starting with a 9. I'm really just copy pasting the same deductive reasoning argument. And I'm 100% certain. Whether I want to see them or not, it depends on the person following the argument. So maybe let's agree to disagree and say it's somewhere in the middle. But yeah, because I'm 100% sure of that 6, and I have a logical argument to explain it, we're just not writing it out, I wouldn't see it as inductive reasoning. Yeah. My initial starting with a 1 just gives me a smaller space to establish the argument that I can then just copy and paste. So we're still 100% confident, but some people might need to see it in more detail, right? And this isn't quite a standalone explanation. So overall, I have 4 groups of 6, so 24 in total. And of course, it depends on you. It depends on the person you might be explaining this to, the amount of detail you need to show and see, of course. But because I'm here to sort of talk through it, there's a video backup you can rewatch. We're not writing out a whole bunch, and you don't need to for a test either. You don't have to necessarily show your structured, systematic way of building this list, but if you don't have a system for making this list, you're going to miss one, almost guaranteed. If I randomly just shuffle them around, I'm going to be confused and not sure. By the time I get to 21, it's going to be really hard to notice which ones are missing. And you don't know what the target number is, right? Perhaps. So how do you know 3 are missing? And if you know some are missing, which ones are there? So it's all about avoiding randomness because that doesn't fill me with confidence. I won't be 100% confident. But if there's a structured way for making this list, sometimes I can see a way to copy and paste that structure and make it even faster. But I don't know if that's a natural first approach that little Timmy's gonna come up with. Somehow I doubt it. But randomness can make things very complicated, and then you're like, it seems impossible. Especially if I add a few more digits and you make that list randomly, whew, there's no way I'm getting them all. No way. And that then adds to the mystery. Oh, it's just magic. Some people just know how to make this. No, it's all about your approach and your strategy. What about 1977? So now I have the issue that, let's do it like this, 1779. I like increasing order to keep track of everything. Now the two sevens are identical. And swapping them around does not yield a different arrangement. What happens now? Well, I've established a basic strategy, a basic plan to get through this list without missing anything. So I'm going to stick to that plan. Why wouldn't it work here? I'm going to stick to my 1 in the first position, stick to a 7 in the second position, and then shuffle the other 2 in all possible ways. 7, 9 I already have. 9, 7 is the other one. And that's definitely different. I'll stick to my 1 for as long as I can. I've now used 7 in the second position. I need to update that. The other 7 is going to be exactly the same. So the only other option is a 9. And then I have 7, 7. I can't swap the 7s and create something different, so that's the only one. So I've gone through all the possible second digits. I have to update the first digit to the next one in line as a 7. Then I'll just go increasing order, fixing the 1 as long as I can, and I can make another one. I can't fix the 1 in the second position and create something else. So I need to update that with the next in line, which is 7. And then 1, 9 is left. And I can create a 9, 1, which is different. Then I'll continue up here. I want to keep the 7 in the first position as much as I can. And I can still do that by having a 9 second. That's still an option I haven't done. 1, 7 is left. And 7, 1 for the last 2 will create something different. Now, keeping the 7 first, I've ran through all the options that could be second. There's nothing left, so I have to update the first digit to something else, and the next one in line is a 9. The other 7 will look exactly the same. Then I'm just arranging the rest in increasing order. I want to keep the 9 for as long as possible, and while doing that, keep the 1 for as long as possible, but the two 7s can't be swapped. They're identical. So I have to update the second position to something else. And then I have 1, 7. Keeping the first 2 the same, I can swap the last and create 7, 1. Those are all my options for 7 in the second position. Update that to the next one, but there is no next one. Oh, that's unfortunate. So those are all the ones with a 7 in the second position, because there's no other one to update. So I don't have any other options. I can't update my first one. I've ran through all the 1s, 7s, and 9s. And while doing that, I've gone through all my second options. So I'm at the end. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12. Oops, I'm in eraser mode. That's why. 12 in total. But you see here I have 3 arrangements starting with a 1. I have 6 arrangements starting with a 7. I have 3 arrangements starting with a 9, sorry. And because the composition changes, sometimes I have identical digits, sometimes I don't. It's a little different at this level. Now, there is much more structure in the background, really, once you go into permutations and things like that. But at an elementary school level, of course, we don't have those tools and shortcuts to know without making a list that it's going to be 12. That's a much more complicated thing to do. We're going to make that list, but we want to make that list in a strategic way to give confidence and not take confidence away. And in doing that, there's a lot of learning that can happen for little Timmy in making such a list in a structured way. So it's a very, very good skill to have, that I always have that experience that if I need to make a list, it's never going to be random. There's always going to be some structure because that's what gives me confidence. All right. How do we feel about that? Your silence speaks volumes. All right, good. That was only the first one. God, what am I? Oh, I was not trying to highlight that. I'm sorry. That was an accident. Next one. Now, don't look too closely at these headings. I'm just trying to section the examples a little bit. When it's in work backwards section, that doesn't mean that's the only thing you must do and you cannot do anything else. No, it's just sort of the main strategy behind these questions. Forget this. Can I remove this highlight? Oh, yeah, I can. Okay, good. All right. Exercise 3.2. Do we have space? 3.2. All right, let's read it first. After completing repairs on an elevator, a maintenance engineer tested his work by sending the elevator up 12 floors, down 18 floors, and back up 20 floors. If the elevator ended up on the 30th floor, on which floor did the engineer begin his test? I hope that no one feels that that question is difficult. But imagining I give this to a grade 2 student, that's going to require some effort on them, some careful thinking, because it's just enough information to not do quickly for them. So it's not all about me being able to do it. It's about me being able to, yes, do it, and be able to explain it as if sometimes I imagine me teaching this. A picture would make a huge difference to me here. So I know where the engineer ends on the 30th floor. So let's put that in the middle. This is the end, 30th floor. Okay. I want to know where they started, which means I have to sort of read this backwards, hence work backwards. So then the question becomes, what came right before they got to the 30th floor? They went up 20 floors. So from somewhere, they went up 20 floors. We'll do it like that. So that means they came from the 10th floor. Then, what happened to get them there? They went down 18 floors. So they went down 18 floors. So that means they came from the 28th floor. How did they get there? They went up 12 floors. My sketch is a little small now, I'm running out of space. 12 floors up, which means they came from the 16th floor. And that's the end. There's nothing more that happened. So they started their test on the 16th floor. Now, of course, you scale how much detail you show depending on what we're doing. If it's you just doing the question, your diagram shows that you've systematically worked through the information. It's all good. You don't need full sentences here. We'll save some time and it's okay. But of course, that doesn't mean you didn't go through the full argument. We just did it verbally. And that can be more difficult for a student to hear and keep track of everything you're saying. So if you're teaching this, depending on the level, you might want to write out some sentences to give them time to keep up with the argument and so on. But for us, and you have the video to watch again afterwards, verbally is perfectly fine. But just know that you should be able to scale your answer's appearance according to your audience. Okay. So working backwards definitely feels much better if I have something to look at and have a picture. If I didn't have this picture, much more difficult. Much more difficult. Draw a picture. All right, that wasn't too bad. And it's really just raising awareness of options that I have to make problems easier. Don't have a lot of space for the next one. So some questions will be fast. Some questions will highlight something that needs a little bit more of a discussion. We'll just let each question teach us what it wants. We certainly have the time. Was it the third one next? Come on, you can open. Third one, okay. Let me just see here. This is the end of the question, yes. I'm seeing the whole question. Let's move it up a little bit. Can I move it up? Thank you. All right, 3-3. Now I also want to be aware of the difficulties that my audience could experience. Just as I'm thinking beforehand how you could potentially perceive problems and how and where issues might arise, when you're thinking of your elementary school class, you can also, or teaching something, you can also think, well, how must this feel for them? If I read this once, I want to be aware of how this could be perceived, not from my point of view, but from the student's point of view. Bob Zwettler goes to the racetrack with his buddies on a weekly basis. One week he tripled his money and then lost $12. He took his money back the next week, doubling it, but then lost $40. The following week he tried again, taking his money back with him. He quadrupled it and then played well enough to take that much home with him, a total of $224. How much did he start the first week? I have no shame in admitting I have no idea how much he started with. Not a clue. Which teaches me that reading this once is not sufficient. It is not enough to read this once and expect yourself to know what to do or know the answer. But that's not what our goal is. Our goal is to simply come up with a plan to help us systematically figure it out. Now, a sketch in this case doesn't feel as obvious to me, so maybe a table would help structure the information and help me keep track of it. Now, the columns that you have in this table, that's totally up to you. I'm just doing what I think might work, and I'd rather have too many columns than not enough. So definitely there's a starting amount. Then it seems like sometimes multiple things are happening in that week. So for example, the first week he tripled his money and then lost $12. So multiple things happen. So I will say here, let's say maybe first change in his money, and then there's a second change, and I'm just coming up with this on the fly. I have no idea. Then what he ends with. Maybe those columns are sufficient, right? I'm just making a plan. That's not the page I was looking for. Where's the page? Did I close it? Oh. There it is. There it is. I'm just coming up with a plan, and I'll self-check and see, is my table sufficient? Is it helping me? Do I need to add columns? Do I have too many columns? That's all okay. Not a problem. Maybe this is good enough. Let's find out. So I want to know, how much do I start with? Ultimately, I want to fill in that question mark. Let's see what they tell me. So, week one. He tripled his money. Okay, so then I'm going to multiply that amount by 3. I just don't know what the amount is. But I tripled it, or he did. Then he lost $12. Oh, poor guy. So then he is going to lose $12. And then he ends with something, right? Let's see here. So whatever he ends with, he's of course starting the next week with that amount. I'm just trying to make a plan here. This is hard for me. I need to go slow. He took all his money back the next week. Then he doubled it. So then whatever amount he had, he doubled that for his first change. That's what I call it. You can call it something else. Oh, then he lost 40. What a shame. Lost 40. And then that's all that happens, right? Then he took that money and he tried again. Oops, sorry, let's label the weeks. This is week 2. This is week 3. One more week. What happened? Oh, he quadrupled his money. So times 4. And then that's what he took home. Okay, that's not bad. So then he ended with 224. Okay, so I'm just laying it out in a way that feels good and clear to me, helping me keep track of what information the question gives me. So now nothing happened after the first change, so this 224 is here as well. Nothing else happened. So now I'm just working backwards. If he quadrupled his money to get to 224, how do I go backwards? This is where you say stuff. You divide by 4. 224 divided by 4. Let's show that we have a calculator in the chat. It's a nice time to show it. I just start with 2 equal signs and do the calculation. And MathBot says 56. Just so it shows in the chat as well. But of course, use your calculator. Do it in your head. Do it by hand. Do whatever you want to do. 56. So then, that 56 following the arrow is gonna be over here. Is what he ended his week 2 with. Now I see here that, I didn't need this many columns. I didn't know it at the start, but that's okay. I'd rather have too many than not enough. That the second change amount is actually what I end with. Oh well, it's not a problem. Doesn't have to be perfect. I had too many columns. Okay. Then, to get to 56, he lost 40, which means he started with $40 more, which means 96 for that first change. To get to the 96, he doubled his money to get to 96, which means I have to divide it by 2 to get to the starting amount. 96 divided by 2. MathBot doesn't get enough action. Let's give him some action. Of course, I know all of you can do it in your head, but maybe little Timmy can't, right? So, oops. So that gives me my 48 that he starts week 2 with. I then follow that 48, realizing that I have too many columns, so that's also 48. So to get to the 48, he lost $12. That means I have $12 more before that happened. And to get to the 60, he tripled his money, so I have to divide it by 3. So this is a 20. Maybe a sentence here is a good idea. He started with $20. Well, that's actually not bad. Ended with 324, started with 20. Wow. Look at him go. Very nice mid-range level question to show working backwards. Where I have too much information to keep track of in my head, I need to see the information. I need to see it and keep track of it. A table might be a really good idea. Really good idea. Now, I will say at this stage, if you really want to take this further and see if you can stay calm and do what needs to be done, there's a problem I want to highlight. Is problem 315, the ultimate working backwards question, that you can really use as a test. Do not look at the answer key. Get the most out of this question. There aren't many of them. See if you can lay it out in a way that makes sense to you, that helps you keep track of everything that's happening. A little more difficult, a little bit more involved, but the same strategy. Okay, we're making progress. It's 9:20. I suppose that is a place to stop. What I want to do first next time is exercise 315. What would be most beneficial is if you, not 315, 3.5. If you think about 3.5 on your own, take like 5 minutes. Just think about this question. See if you can do it. Don't Google it. Don't try and find the answer. Just give yourself some time and see if you can do it. And if you can't, totally fine. But even that 5 minutes, it makes you better. Even if it results in seemingly nothing, it makes you better. And we'll start with this one next time. This problem 3.4 is a little out of place. I want to do it much, much later. So 3.5 is where we'll start, and then we'll just continue from there. Any thoughts or questions at this stage?
No, this seems pretty interesting.
All right.
The pace.
So yeah, we're not going fast. I strongly encourage you, take 5 minutes, maybe take 10, take whatever you want, whatever you can stand. And just give this one a shot. There's no calculation. It's just, can I understand the question and can I come up with the answer? And then we'll start with that. And there are some other problems we can work on, seeing or showing all the strategies that I should keep in mind. All right. Until tomorrow.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.